Okay, so welcome back and let's keep going. So we're currently on exam 2 from 2016 fall semester. We're on question number 8. This is a question on the molecular orbit topic that we've been going through during the chemistry lectures. So it says which species has the largest numbers of unpaired electrons in the ground state? And there are the whole bunch of the diatomic molecules listed. And the way we need to do to approach this kind of problem is just we try to fill the molecular orbit we have over here with those the given diatomic molecules. So let's take a look at all these answers. So the first one is difluorine with like just actually fluorine gas, but it's a fluorine gas with one positive charge, which means there's one electron missing. And for fluorines, as you can see, fluorine is over here, so that's why we need to use this. We need to use the left one. We need to use the left one as the our. Uh, I'm sorry, the right one. I'm sorry, I can't tell the difference between left and right. The right one as our primary orbits, and so let's try to fill up. So as you can see, chlorine has a two s orbit, two electrons in the s orbit, and 7 electrons in the p orbits. So 7 electrons in I mean 5 electrons in the p orbits. So let's try to fill up the entire thing and see how that works. So perhaps I'll try to fill it over here, so it works better. No. Yeah. So let's fill it up, and since it's I think I accidentally drew one extra electron over here. Since it's a F2 plus, which means it's one less electron than a real fluorine gas, we just remove an electron from whichever we want. Let's pick the right side on this side. Actually, it can be on both sides. It can be like on either side, I mean. So it doesn't really matter if you want to do it from the left or the right. Now we're doing it from the left. So we already filled out the S part of it, and let's fill out the P part. So there's 1, 2, 3, 4, 5, 6, 7. Did I exceed 8, 9? And as you can see, there's one unpaired electrons in the entire molecular orbit for the F2 plus. Let's remember that, and let me just get a bigger eraser. Let's clear the entire thing up, and let's write down the answer over here. It's quite easy to do with computers. So very nice then. So let's switch it back to a small eraser, and let's write down. So one unpaired electron, and for the neon gas, the di-neon molecule, I would actually like in the beginning, like if you're approaching from a faster way, you should recognize that neon, which has 8 electrons on each side, they have 16 electrons. There's usually no like it will fill up the entire molecular orbit, which will leave no chance for a lone pair electron. But let's just fill it up for fun right now. So they have 2 electrons in each respective s orbit, and why in the world this pen is over here again? Go back. Oh, never mind, it didn't work. Oh, Lord, no. Uh, oh, come on. Should I just click on the add pen or stuff like that? Alright, come on, go back. I'm so desperate. Let's just switch color for this particular moment, and let's fill up all the Oh, I probably should do it in like a proper manner. So it's something like this. Okay, so and let's try to fill up the molecular orbit afterwards, which as you can see neon is over here. I probably forgot to mention it. Okay, great. My pen is got back, and let's switch it back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you can see there's no unpaired electron left within the entire molecular orbit. And let's clear this up. Oh man, this is so satisfying. wait, it's not responding to my, oh yeah. So there's 0 for neon. And let's take a look with oxygen, the oxygen plus. And oxygen has 6 electrons, which means 1, 2, 3, 4, 5, and 6. So on each side, 2, 2, 3, 4, 5, 6, and oxygen over here has 6 valence electrons. Let's fill up the entire orbit real quick. 1, 2. So as you can, did I do it too much? I think so. I accidentally. No, I didn't. There's 4 on this side, 4 on this side. So there's a total number of, yeah, I did it correct. So as you can see, there's 1, there's 1 and 2. So there's lone 2 lone pair electrons. So there's a 2 unpaired electrons. I should do it with the same color. So it's 2 unpaired electrons. And this one is just oxygen with 1 extra electron, so just plus 1 extra electron. And it should be placed here, as you can see. So it's just a 1 for question number D. It's just one extra electron from whatever we just did. Oh, I'm so sorry. Yeah, it's oxygen plus. So it's just we should remove 1 electron from whatever the oxygen we like. So let's just move it from the right side at this moment. And so it's we can only fill up this part, and which leaves with 1 unpaired electron. I'm still not trained enough. And oxygen minus is just oxygen plus 2 more electrons. So with 1 more electron. So we just put 2 more electron in. We just put 2 more electrons in the orbit, which results something like this. So it leaves with 1 unpaired electron. And the oxygen itself is just removing 1 electron from whatever the orbit is. So let's just remove this one. So it leaves 2 unpaired electrons. So as you can see, there's 1, 0, 1, 1, and 2. So E is the correct answer, I believe. And then let's stop here.